Now I would like to introduce a software, OpenCalphad CAE, a graphical user interface, GUI, of the free thermodynamic calculation software, OpenCalphad. This is the outlines for this presentation. Number 1. Short introduction of OpenCalphad. Number 2. A suite of OpenCalphad-based free tools. Number 3. OpenCalphad CAE, its structure and interface design. Number 4. Installation of OpenCalphad CAE. Number 5. Step-by-step example for property diagram calculation of high-speed steel. Number 6. More application examples. Here is a brief introduction to OpenCalphad. OpenCalphad, which is called as OC, is a free computational thermodynamics software which can be used as a computational tool in materials science. OC can handle equilibrium calculations for multi-component systems with a very flexible set of conditions and includes most of the models used in the CalPhad community. OC is executed under the command mode, console mode, and can calculate and output property diagram and phase diagram. OC Application Software Interface, ACASI, is available for user-developed codes like Fortran, C++, or Python, TQ mode. Based on the OpenCalphad engine, a suite of OpenCalphad-based free tools can be developed. The original OpenCalphad Fortran codes can be compiled as an executable file, which can read a macro file to perform a thermodynamic computation. Such an application program with graphic user interface is called as OpenCalphad CAE. If you would like to make your own program, you could use TQ interface. TQ interface is an application program interface (API), which is developed to Fortran and C language users. Furthermore, OpenCalphad Python is also available by using F2PY and F90 wrap tools. If you are interested in OpenCalphad Python, which is a Python interface, you can download it through the link below this video. OpenCalphad CAE is a graphical user interface that simplifies the environment for using and developing OpenCalphad applications. It is written mainly for its educational purposes. By using this program, you will learn how to use OpenCalphad to carry out thermodynamic calculations with this easy-to-use interface. OpenCalphad CAE has been developed for help user to get thermodynamic calculation results quickly based on OpenCalphad engine. This figure illustrates the structure of program for the basic version of OpenCalphad CAE. From left to right, it shows 3 blocks. The first is input data preparation, the second is the generation of OpenCalphad model that is macro file, and the third is the execution of computation, finally output of results by means of the grapher tool GNU plot. 4 calculation types are available: single equilibrium, property diagram, phase diagram, and advanced application. The window is snapped to 8 zones according to the layout. Zone 1 is Menus Zone, which includes File, Start, Database, Tools and Help. Zone 2 is Toolbar Zone, which includes New, Open, Save, Macro Build, Macro Read, and OC Command Line. Zone 3 is Node Tree Zone, which includes 2 sections, Computation and Output. Zone 4 is Action Zone, which consists of individual tab widget that corresponds to the content in Zone 3. Zone 5 is Results Zone, in which the graphic result is plotted via GNU plot, and data results are listed. Zone 6 is Text Editor Zone, in which the texts of macro file can be modified. Zone 7 is Log Information Zone. The actions are recorded and displayed in this zone. Zone 8 is Status Bar Zone, which shows the current module and the current project name. Now I show how to download and install Lottie, the OpenCalphad CAE package. Step 1. Download OpenCalphad CAE setup file. The download link is also given below this video. Step 2. Install OpenCalphad CAE. Double-click the OC_CAE_setup_verxxx.exe file. Step 3. Run OpenCalphad CAE from desktop or Start menu. Step 4. Go to Menu, then Tools, then Download and install GNU Plot. Step 5. Check the settings for GNU Plot through Menu, then Tools, then Settings. The important thing is the location of GNU Plot. You may also download 2 PDF files. The first is OpenCalphad CAE User Guide, OpenCalphad CAE_user_guide.pdf. The second is step-by-step examples for OpenCalphad CAE, OpenCalphad CAE_step-by-step_examples.pdf. Use the following steps to run a quick case using the macro build module. Step 1. Click Macro Build button or New button in the toolbar. Step 2. Click Tree Node Compositions in Macro Build panel in the Node Tree area. A tab widget comp appears in the middle of the window. Step 3. From the database list, choose Steel 1. Step 4. From the major element list, choose FE. Step 5. Choose Radio button Read from file. Step 6. Click Push button Read. Step 7. Browse to the subdirectory /materials. Select the data file hss.json. Step 8. Click the Open button. It then shows a composition table. Step 9. Click Tree Node Conditions in Macro Build panel in the left side and a tab widget cond appears in the middle of the window. Step 10. Choose Radio button Property Diagram and change EQ temperature as 1200. Step 11. Change Equilibrium temperature as 1200. Step 12. Change Minimum temperature as 800. Step 13. Click Push button. Next Output Definitions. A tab widget Out-P appears in the middle of the window. Step 14. From Y-axis Output Name, choose Moles of Phase. Step 15. Click Push button, next Execute. A tab widget Exec appears in the middle of the window. Step 16. Click Push button Generate macro file and Push button Run macro file is activated. Step 17. Click Push button Run macro file. Step 18. One console window and one GNU plot window appear. Click the cross symbol to close the GNU plot window and console window. In the results zone, the results for the equilibrium calculation are shown. Step 19. Click Push button, next figure. Step 20. Be sure that Radio button Original GNU plot is checked and select FIG1 from figure list. Step 21. Click on Push button Plot. Step 22. Click on Push button Generate modified GNU plot. Now Radio button is activated. Step 23. Check this Radio button. Step 24. Click the Push button Plot. Now you can modify your GNU plot. Step 25. Uncheck the checkbox Show Title in GNU plot figure. Step 26. In the edit box Xmax, type 1800 as X-axis maximum value. Step 27. Check the checkbox Show Only Names for Phases or Constituents. Step 28. Click the Push button Plot. You can see the modified figure Fig1_mod. Step 29. Click Push button Save. A new window appears, which has a title of Create New Folder and Save As. Step 30. You are asked to give a project name. You can type property_diagram_HSS. You can see a path plus name is added to current project in status bar at the bottom. You can open this saved project later. More examples are available. Please refer to step-by-step examples for OpenCalphad CAE. Thank you for your interest in OpenCalphad CAE.